Hello friends, welcome to Learner's Planet. Friends, in the previous session, we discussed various types of polynomials, that is linear polynomial, quadratic polynomial, cubic, biquadratic, right? Then we discussed about their zeros. Then we discussed the relationship between coefficients of a polynomial and their zeros. We did good number of problems as well. In this session, we'll be taking more problems based on relationship between zeros and coefficients of a quadratic polynomial, right? So let's begin the session. Now friends, let's discuss this question. If alpha and beta are the zeros of the quadratic polynomial fx is equal to ax square plus bx plus c, then what's the value of alpha square beta plus alpha beta square? Now if alpha and beta are zeros of this, that means in the previous session we have already discussed that sum of the roots will be minus b by a. Similarly, product of the roots is c by a, right? So we know the value of alpha plus beta and alpha beta both as well, and we have to find out the value of this. Now it's what? Alpha square beta plus alpha beta square. Now if we take alpha beta as common, we'll be left with alpha plus beta. Now precisely we know the value of alpha beta and alpha plus beta both as well. So just put the value. Alpha beta is c by a and alpha beta is minus b by a. Right? So it's minus bc by a square, right? So it's minus bc by a square, right? Now, similarly in this question we have to find out the value of this expression. Further, alpha plus beta we know. For this expression, alpha plus beta is minus b by a and alpha beta is equal to c by a, right? Now take LCM of this. It's a beta plus b plus a alpha plus b, then a square alpha beta plus ab beta plus ab alpha plus b square, right? So in the numerator it's a plus b, then it's a alpha plus a beta, right? So we can take a as common. Sorry, it's b and b. So 2 times b we are having, then plus we can take a as common. So it's a, then it's beta plus alpha or alpha plus beta, right? Then it's a square alpha beta. So it's a square alpha beta plus, from these we can take AB as common, AB alpha plus beta plus B square, right? Now we have to put the value of alpha plus beta and alpha beta, right? So let's put the value over here. It's 2b plus a. Alpha plus beta is minus b by a, so I put minus into b by a, right? So it's 2b plus a into minus b by a, right? So it's 2b minus b in the numerator, right? In the denominator, I just solve it over here. This is numerator. It's a square alpha beta, so a square into c by a plus ab into alpha plus beta, that's minus b by a plus b square, right? So it's this, and it's minus b square and it's plus b square, that's cancelled, and this what? AC, right? So in the denominator we have AC. In the numerator we were having b, in the denominator it's AC. So final answer is b by AC, right? So that's option D over here, right? I hope you are clear. Now friends, we have this question. Alpha and beta are two numbers such that alpha plus beta is 6 and alpha minus beta is 8. Then alpha and beta are the roots of quadratic equation. Now sum of roots is 6 and difference of root is 8. So first of all, let's calculate the value of alpha and beta. We have simultaneous equation where alpha minus beta is 8 and alpha plus beta is equal to 6. So if we add both of them, we'll be getting 2 alpha is equal to 14, that means alpha is equal to 7. Now if I put the value of alpha in any of the equations, suppose in this, so 7 minus beta is equal to 8, that means beta is equal to minus 1, right? So we got the value of alpha and we got the value of beta. Now what will be the quadratic equation? There are two ways of doing this. We know the roots, that's 7 and minus 1, so we can frame the quadratic equation like this: x minus alpha and x minus beta. This is what the quadratic equation when the roots are alpha and beta. Now we just have to put up the value of alpha and beta both. So x minus 7 and x minus minus 1, that's x plus 1, right? So if we simplify that, we'll be getting the quadratic equation. So it's x square minus 7x plus x minus 7. So it's x square minus 6x minus 7. This is the quadratic equation. Okay, I hope you are clear. This is the quadratic equation whose roots are alpha and beta, provided coefficient of x square is 1, which is there in all the options, right? So you can directly put the value of alpha and beta over here. Okay. Now, in this question, if 1 is one of the zeros of the polynomial x square minus x plus k, then the value of k is, right? Now, 1 is the one zero and we take alpha as other zero, right? So the zeros of this polynomial is alpha and 1. Now, what will be the sum of zeros? That's minus b by a if we talk about ax square plus bxc. So the sum of roots will be minus b by a. So here it will be 1 only, right? Okay. Similarly, product of the roots, that is alpha into 1, that's k. Alright. Now from here alpha is 0, that means k is also 0. Right. I just make a quick recap over here. Here alpha plus 1 will be minus b by a according to this relationship, and alpha into 1 is c by a, right? So we just have to put the value of a, b and c over here, right? So alpha plus 1, alpha into 1, but that's product of the roots is k by a, that's 1. Okay. If the sum of the zeros of the quadratic polynomial ft, that's kt square plus 2t plus 3k, is equal to their product, find the value of k, right? Now sum of zeros is equal to their product. I assume the roots are, or the zeros are, alpha and beta. So according to the given relationship, alpha plus beta is equal to alpha beta. Now if we make the comparison of this equation from ax square plus bx plus c, so alpha plus beta is equal to minus b by a. So from this equation it will be equal to minus 2 by k, right? Coefficient of t by coefficient of t square in negative, right? Similarly, alpha beta will be equal to 3k by k. So it's 3, right? Now we put the values of alpha plus beta and alpha beta in this given relationship, where we are given that sum of zeros is equal to their product. So alpha plus beta is minus 2 by k and alpha beta is 3. So k will be equal to minus 2 by 3, right? So k will be equal to minus 2 by 3. I hope you are clear. Now in this question, if one root of the polynomial is reciprocal of the other, then the value of k is. Now suppose the one root is alpha, that means the other root should be reciprocal of that, that means the other root should be 1 by alpha, right? Now what? Product of the roots is what? If we talk about ax square plus bx plus c, then product of the roots, that's c by a, that is constant term by coefficient of x square. So similarly over here, product of the roots will be what? Alpha into 1 by alpha, that's product of the roots, and actually it will be constant term by coefficient of x square, right? So it's k by 5. Now alpha into 1 by alpha is 1, so k is equal to 5, right? Now in this question, alpha and beta are zeros of this quadratic polynomial and alpha square plus beta square is 24, that's given. We have to find out the values of k. Now what will be alpha plus beta? In this case it will be coefficient of x by coefficient of x square in negative, right? So it's minus 4 by k. Similarly, alpha beta will be equal to constant term by coefficient of x square, that's 4 by k. Right? So we got the value of alpha plus beta and alpha beta. Now what's alpha plus beta whole square? It's alpha square plus beta square plus 2 alpha beta. Now we put the value of the expressions which we know. Now alpha plus beta is what? Minus 4 by k. So the square will be 16 by k square is equal to alpha square plus beta square as given as 24 plus 2 alpha beta is 2 into 4 by k. So it's 8 by k, right? So we got further a quadratic equation in this format. So let's solve it. First of all, we can take 8 as common. I assume 1 by k. Okay, we just can take LCM as well. First of all, I take 8 as common and simplify this. So it's 2 by k square is equal to 3 plus 2 1 by k, right? I took 8 as common. So 8 3s are 24 and 8 2s are 16. Now let's take LCM. So it's 2 over k square is equal to 3k plus 1 by k, right? So it's 2k is equal to 3k cube plus k square, right? Or we can just simplify it like this also. So it's 2 is equal to 3k square plus k. So that means 3k square plus k minus 2 is equal to 0. Now we have to factorize. We have to find out the value of k when the product is minus 6 and sum is plus 1, right? So it's 3k square plus 3k minus 2k minus 2 is equal to 0. So it's 3k, k plus 1 minus 2, k plus 1 is 0. So 3k minus 2, k plus 1 is 0. So k is equal to 2 by 3 or minus 1, right? So this is how we can solve this problem. Okay. So the value of k which we are getting over here is 2 by 3 or minus 1. So we have 2 by 3 in option. So we can choose that. Right? I hope you are clear. Now alpha and beta are zeros of the quadratic polynomial this such that alpha minus beta is 1, then the value of k. Now if alpha and beta are zeros, then alpha plus beta will be equal to, that's coefficient of x by coefficient of x square in negative. So it will be 5. And alpha beta is constant term by coefficient of x square. So that's k. Now alpha plus beta is 5 which is given to us, and alpha minus beta is 1, that's also given. So we can get the value of alpha and beta both as well. Just add these equations. So 2 alpha is 6, that means alpha is 3, right? If alpha is 3, if we put the value of alpha over here, so we'll be getting the value of beta, that's 2, right? So alpha is 3, beta is 2. Now we put the value of alpha and beta over here. So k will be 3 into 2, that's 6, right? Now in this question, the roots of quadratic equation this are in the ratio 7:6, then the value of k. So we assume that the roots are 7p and 6p, right? Now what will be the sum of the roots? 7p plus 6p, and sum of the roots is what? Coefficient of x by coefficient of x square in negative. So it's k by 3, right? So k by 3 is what? 7 plus 6, that is 13p. Similarly, product of the roots will be what? It's 7p into 6p. It's that constant term by coefficient of x square. So it's 14 by 3. Right? So the value of p square is what? P square is equal to 1 by 9. So p is equal to plus minus, p can be positive only, so p is equal to 1 by 3, right? Now from, I just assume this to be the second relation. Now I put the value of p in this equation and I can get the value of k, right? So k by 3 is equal to 13p, that means 13 into 1 by 3, so k will be 13, right? Now, quadratic polynomial having zeros 1 and minus 2. So whenever you are given zeros of a polynomial, quadratic polynomial I mean to say, you just put the value over here. So standard quadratic polynomial is this, when the roots are or the zeros are alpha and beta, right? So for any quadratic polynomial, if the roots are alpha and beta, this will be the quadratic polynomial. Now here in this case, alpha and beta are 1 and minus 2 respectively. So I just put the value of alpha and beta over here. So it's x minus 1 into x minus beta. So beta is minus 2, so it will be x plus 2, right? So it's x square minus x plus 2x minus 2. So it's x square plus x minus 2. This is the quadratic polynomial having zeros as 1 and minus 2. So you just remember this, right? If a quadratic polynomial having roots as alpha and beta, that can be presented in this form, right? So it's x square plus x minus 2. Okay? Similarly, quadratic polynomial having sum of its zeros is 5 and product of its zeros is minus 14 is. Now sum is 5 and product is minus 14, right? So what we can do, either if the questions are option based, we can see that where the sum of root is 5 and product is minus 14 from the options, right? Now sum of the roots is 5, that's there in this option and this option, right? So these two are wrong. Now product should be minus 14, that means the constant term should be minus 14, so that's there only in this option, so even this is incorrect. This is correct, right? And if you are asked the question in subjective questions, then you have to solve it, right? Now how do we solve that? Just listen to me carefully. See, alpha plus beta is 5 and alpha beta is minus 14. So from this equation, I get the value of alpha or maybe beta. So beta is equal to 5 minus alpha from this, right? Now the value of beta I'll put in this equation. So alpha into 5 minus alpha is equal to minus 14. So it's 5 alpha minus alpha square is equal to minus 14, or I can say alpha square minus 5 alpha minus 14 is equal to 0. So alpha square minus 7 alpha plus 2 alpha minus 14 is equal to 0. Alpha minus 7 plus 2 alpha minus 7 is equal to 0. So alpha plus 2 alpha minus 7 is 0. So alpha is equal to minus 2 or 7, right? Now if alpha is equal to minus 2, beta will be equal to 5 minus alpha over here. So beta will be equal to 5 minus minus 2. So it's 5 plus 2, that means it's 7, right? And so we got, and the other thing is, if alpha is equal to 7, beta will be equal to minus 2, right? So precisely one root is minus 2 and other root is 7, right? Now if we got the two roots, we can frame the quadratic polynomial as we have discussed. It's x minus alpha and x minus beta, right? So alpha is 7 and beta is minus 2, right? So just multiply this, x square minus 7x plus 2x minus 14. Okay, so it's x square minus 5x minus 14 is equal to 0, right? So this is what the quadratic equation is. So that's option A. I hope you are clear. Now friends, let's discuss this question. Quite an interesting problem. Just listen to each and every word very carefully. If alpha and beta are zeros of this polynomial, then the polynomial having 1 upon alpha and 1 upon beta as its zeros. Now this is what its zeros are, alpha and beta. So alpha plus beta is equal to what? It's minus p, and alpha beta is equal to q, right? That is of this equation. So this is the first relationship with us. Now we have to find out the quadratic equation whose zeros are this, right? That means 1 upon alpha and 1 upon beta, right? So sum of zeros of new equation will be 1 upon alpha plus 1 upon beta, right? So that's what alpha plus beta upon alpha beta. So I can put the value of alpha plus beta and alpha beta over here. So it's minus p by q, right? So sum of zeros of the new quadratic equation is minus p by q that we got, right? Similarly, we can calculate the product. So that's 1 upon alpha into 1 upon beta. So it's 1 upon alpha beta. And what that will be? It's 1 by q. Right? So for the new quadratic equation, we have sum of zeros and product of zeros. Now how can we frame a quadratic equation whose sum and product is known to us? So that's x square minus x sum of zeros plus product of zeros, right? So this is the standard quadratic equation in which we have already discussed that, and we in this we can directly put the value. Now x square minus x, sum of the zeros was minus p by q, so it's plus x p by q. Similarly, product of the zero is 1 by q. I just put 1 by q over here, and that's the quadratic equation, right? So precisely it is qx square plus px plus 1 is equal to 0 if I take the LCM, right? So this is how we can solve this sum. Getting my point? Alpha plus beta is given to you as minus p from this equation or from this polynomial. Secondly, alpha beta is q. Now sum of the zeros of new equation. Here we are asked about polynomial. Doesn't matter, you can make a equation or a polynomial. If it is equal to 0, then it will, if the polynomial is equal to 0, it is converted to equation. So maybe it's a polynomial, it's an equation. Precisely we have to find out sum of zeros, right? So that's 1 upon alpha plus 1 upon beta, and that's alpha plus beta by alpha beta. So by putting the value of alpha plus beta and alpha beta from here, we can get the value of sum of zeros. Similarly, we got the product of the zeros, that's 1 by q. Now for any quadratic equation, if we know the sum and product of the zeros, this is the format of the quadratic equation or quadratic polynomial, right? So here I put the value of sum of zeros, I put the value of product of the zeros, and I got this polynomial, right? Since we are asked about polynomial, it will not be equal to 0, right? So it's this only. So it's qx square plus px plus 1 by q, right? So this is what the quadratic polynomial, right? You use q or you do not use q, doesn't matter, right? Because when this quadratic polynomial is equated to 0, it will be converted to an equation, and it will be by multiplication, cross multiplication, it will be 0 only, right? So precisely qx square plus px plus 1 is the correct answer. Qx square plus px plus 1. Right? Friends, we'll be taking more conceptual problems in the next session. Do revise this session and the previous sessions as well. Bye-bye.